Happy Monday, everybody. How's it going?
It's going well.
Hey, happy Monday.
Hey,
Happy
what's
Monday.
up?
Welcome,
Happy
Cody and
Monday.
Will. Thanks for joining
Yeah,
the
good
show
to see you
today.
guys. It's cool. Did you guys have a good weekend?
Yeah, it was good. It was a lot of traveling. We were actually in New York last week for a conference.
Oh, that's funny. Okay, well, next time you're there, I'll have to try to connect with you guys.
What conference
Yeah.
was it?
Oh, it was like kind of a boutique thing on data and AI. It was kind of like a more local thing where we had connection.
360 Data plus AI Forum, I think it was called.
Yeah,
Technically,
something like that.
yeah.
That's awesome.
Yeah,
Yeah,
it's
you
really
all know a bit about that space, so
Yeah. So it's very fitting. Yeah.
yeah, that's cool. Yeah, let's hop into it. For people who don't know who you are, do you want to give a quick intro?
Yeah, totally. So I'm Cody Coleman. I'm a co-founder of Coactive alongside Will, and I serve as the CEO. My background is I've been working at the intersection of data, systems, and AI for over the past like 10 years, from like doing research at MIT and Stanford and Harvard to working at places like Google, Meta, and Pinterest.
So again, my name is Will. So Cody and I met back at MIT. Following that, I had a lot of different research positions at different places, and similarly, did my PhD really around a lot of things. One of the core tenets was really like data, particularly within the context of IoT and within the context of neuromorphic computing. And yeah, following that, worked at eBay as a data scientist, and then linked up with Cody and decided to start Coactive.
Why not? That's cool.
Yeah.
I think Cody,
Yeah.
we met at the I think we met at the first MLOps meetup
Yeah.
in San Francisco like a couple years ago back. I think it was like the first meetup after the pandemic, so that was
It was kind of during the pandemic, wasn't it? I mean, it was kind of under.
I guess it was still going on. Yeah. It never happened, Matt. Just kidding. But yeah, that was interesting because it was I think the first time the tech community had gotten back together, the AI community. So it was really cool to run into people like you. Your name came up a lot, Cody, because it was like, that's Cody. He's like the ML perf guy, and he's like really, really smart. And in a room full of people like that, I was like, okay, he must be pretty cool. So yeah, that was a good intro.
Wow, that's awesome. Flattering it, but yeah, I mean, it's so nice actually thinking about that MLOps event. Like that was like one of the first ones post pandemic, as things are like, or not post pandemic, but when it was like finally okay to like go and meet up with people and things like that. And I don't know, it was such a like magical event actually seeing people in person, getting to meet you, Joe, and like Demetrios and stuff like that. And I don't know, I maybe I'm old fashioned, but I really miss those like in-person events where you get to talk to folks like that, like the conference that we were at last week, and like all the events that are kind of scheduled over the next few months.
Yeah, that's been refreshing after as the pandemic, and then just getting to meet people again in person and just getting to really connect. The Zoom is cool and like facilitates like really awesome things like this. But I don't know, it's just like something special about meeting people in person and just just hanging out with them and just chatting. It's fun.
Yeah,
I feel like it's still really good for work, to be quite frank. I mean, getting a PhD as well, like just having those conversations in person with people in your program or going to a conference, it just makes such a big difference in terms of starting collaboration, starting work together. Zoom is great, but it just doesn't, I don't know, we're still humans that like to be in the same physical space.
Yeah, I mean, Matt, I can't tell you how many times someone like saved me a week worth of work because I was talking about something in like the room, and someone was like, no, don't do that. I tried that like a year ago. Like that doesn't work. And they're like, oh, okay, cool. I don't have to do that now for the next 2 weeks.
Yeah.
And it's just hard to have those kind of moments like when you're not in person.
Yeah, I mean, we're biased. We're in person right now in our office in San Jose. So I'd like, even though it's been like kind of crazy with remote work, we were like, all right, as we're starting Coactive, we want to be in person, especially for the early days. It's so nice as you're just like exchanging ideas and things like that.
Mm-hmm. There's something to be said for that. I mean, in-person stuff. I mean, I literally just took a plane to France to give like an hour talk in person, right? Like that's, the efficient part of me is like, oh, you could just do this on a Zoom call, but then miss out on a lot of the serendipities. Just like when you went to that conference in New York last week, right? Like that's, just a really cool thing. And there's also the happy hour there last week. Ethan Aaron's, wasn't that last week, Matt?
That was actually, so that was 2 weeks ago, and then last week was David Riven NYC, which
that's right.
Matt runs, and then had a cool kind of meetup last night with Ethan Aaron and Jess Haberman and Chris Tabb and Holland Nelson.
Sick.
So
yeah,
which is cool. I mean, we actually hashed out all kinds of ideas about a book we're working on, and like got lots of very constructive feedback, let's say. And yeah, it's just different meeting people over dinner, over coffee. It really is. What do you guys think about the future of remote work? Because I think that's a big question for the tech majors like Amazon and Google that are trying to bring people back to the office. But what about for startups? Like, are they going to start bringing people back to the office because they do want people to be in person to interact, or what's going to happen?
Yeah, so super great question, Matt. Again, I'm biased in this, but my perspective is that I think it somewhat depends on, so one, I don't think that there's like one size fits all. I think if you're doing like maybe a consulting startup or something like that, then maybe it makes sense to be remote and you're a consultant because you're like individually working on things. But I think for like product-based startups like Coactive, being in person is just super like special and nice for being able to have that quick exchange of ideas, to be able to see kind of across the company really like quickly, like we can like go and talk to someone that's like, someone hears something from sales, like a sales call, they can immediately kind of give the feedback to the rest of the team, and just like the fact of like broadcasting and stuff like that. Plus just building trust, I think there's something about like actually like grabbing coffee, like having a meal with people and all those little things where like when you're remote, I think it can be a little bit hard where some people you'll only interact with when you have a problem, I feel probably bad for anyone that's in HR. Like they're probably only getting pinged when there's like some issue or something like that. Whereas like in person, like you actually get to interact with the person outside of problems at lunch and stuff like that, and realize that they're like, just a normal human being like everyone else. And I think, especially as you're trying to move fast and things like that, there's a lot of trust, but I know.
Yeah, no, I think plus one, everything Cody said. I think one thing I think is really interesting, right, is like if you're running a remote company, a lot of the advice that you get is like, hey, you have to be really thoughtful about remote. You have to be really thoughtful about how you work together. You have to be really thoughtful about how you like collaborate together. I think the point is often missed is that I think if you're actually doing in person now, you have to do the same, right? Like the option for remote work now exists. So if I'm going to a place and you're not thoughtful about my in-person experience, then why the hell am I here, right? Like frankly, I could just be working from home, right? So I think that the cat's out of the box, right? Like the whole notion of like 10 years ago, like, oh, that doesn't work, it's BS. Like you can actually very much do it, right? So I think whether you're remote or whether you're in person, just being really thoughtful about it and offering like a really amazing experience for your employees is almost a must. And anyone that's kind of like in the middle and it's not really committing halfway, or is not really committing all the way to either experience, I think it's going to be the ones that are really going to they're going to hit a wall with recruiting. They're going to hit a wall with retention. Because I mean, again, I'm remotely and I feel like, hey, I need to be in person, or if I'm in person, I need to be remotely. Like this whole transition of employees finding what they like is happening, right? So you better be like sure you're offering like a first class experience in either. But again, just I think being thoughtful about both is super important. The one question I still have though regarding remote, I think a lot of folks have shown here's how you could be productive remotely. The one thing that I think is still kind of like at least I've yet to see like a very, very strong argument is like here's how you build a strong culture remotely. That one I think is harder. I've seen some folks trying to do like on-sites and things like that, but I just think it's a lot harder. But again, that's our own personal bias.
Sure. And kind of on that same thread, I mean, kind of looping back to when you all introduced each other, like, how did you end up working together? I mean, you both come from, I think, very strong backgrounds, and serendipitously met. I mean, what was sort of the genesis behind you all deciding to work together?
Oh man.
Oh yeah. So we met at a program even before we started MIT. It was called Interface. It was a program run by the Office of Minority Education at MIT. The whole idea is like, hey, all the people from MIT are coming from like really, really amazing like private schools. You guys are coming from like, first generation, low income, like minority, like probably like a not that great of a public high school. Let's kind of get you ramped up to like go to like the best in class like school like that is MIT. it was an amazing program, and it was like an awesome experience. And the funny thing is, that's where I met Cody. That's where I met a lot of my good friends. That's also where I met my wife, actually. So yeah, it's a good program.
Yeah, Will's like the endorsement or like poster child of that program, but
Yeah, I should write them a letter or something.
yeah,
Hey, make business partner, meet your wife. Yeah, it's a good endorsement. It's pretty cool.
Yeah, but it's kind of crazy. That was like, I guess close to 14 years ago now. We're coming
14.
up on, we're coming up on our 10-year anniversary. So like, yeah, we met back then, and then both started out doing computer science and things like that. And we were friends kind of all throughout like undergrad. And then like our paths kind of just kept like crossing. So Will did his PhD out in Chicago at Northwestern. I worked in Chicago for a little bit at Jump Trading. And then, we basically did things in reverse. Then I like decided to go back and do my PhD at Stanford. Then then Will finished up his PhD and moved out to the Bay Area. And Will asked the one, the question you should never ask a PhD student, which is like, when are you gonna finish, and what do you want to do next? And immediate existential crisis of like, oh, do I want to go the academic route? Do I want to work in industry? Do I want to go and start something in the ML system space? And Will was like,
I was like, nah, you should start a company. This is the right call. This is sounds like a good idea. Yeah. And I was like, hey, let's keep talking. I was about to start my job, and Cody was still a year out from graduating, so it was it's a super early conversation, but sure enough, that progressed slowly over time. I think a year later or so, we I quit my job. Cody's graduating. We started the company. I think Cody defended his thesis on a Friday. We started the company on a Monday. So it was.
Oh wow!
It was
hardcore.
No, Cody got the whole weekend. So
yeah, which is more than most of my time during the PhD. Yeah, it's but no, it was actually kind of funny because we were both experiencing or seeing the same problem, but from two different ends. Ultimately the kind of big thing that's happened is I think, and the title of this talk is just unstructured data has exploded as we have a tremendous amount of content. And I was able to see that firsthand at places like Pinterest and Facebook Meta and things like that. And just see how all this content was driving so much business value. But to actually unlock that value, you needed a whole set of kind of bespoke systems and tools and things like that you could only see at these kind of leading companies. And then Will was at the other side of it, again, seeing a tremendous amount of content at eBay. But
yeah, and what's interesting there is, to Cody's point, right? I think if you're when you're in the fangs, right, there is enough of a playbook and there is enough resources that there is something, even if it's kind of stitched together. But oftentimes, what I saw at eBay is it was really interesting, right? It was simultaneously we were kind of ignoring unstructured data, even though it was becoming more and more important part of the user experience. And yet we were analyzing all this other structured data to death, right? And that's kind of the paradigm that didn't make sense to me, right? We care about like half a percentage changes and all these metrics will mean a tremendous amount of things for the business, and yet, our experience was just increasingly based on images. It was increasingly based on the unstructured content, right? The titles, and yet that was really, really, really challenging for us within the context of a data team to analyze. Frankly, it was tough, both from the standpoint of what it took, but also from the standpoint of just the infrastructure, what was available to us. And so that was a lot of the light bulb moment for me. I mean, quite frankly, that's why we started the company, because I was look, this is a tool, if I had, I would have used, right? So there's a need for this, right? This doesn't exist now, but I think our strong conviction when we started this, and in 5 years, it's going to be a no-brainer. People are going to look back and be, wow, I can't believe we were doing all that and now looking at unstructured data.
I have a question about unstructured data, which is, right now, a lot of the techniques with unstructured data focus actually on turning it either into semi-structured or structured data. So, for example, if you go to Google Cloud Platform and you look at their Vision API, you can pass in images, and then they will pass you back a JSON object with some different, key values and such, and says it looks like a dog, or it looks like a cat and a dog, or something like this. Is that going to continue to be the approach, or are we going to evolve away from that intermediate semi-structured or structured step?
Yeah, that's a super good question, Matt. I think that we're going to see kind of a superset of ways to interact with unstructured data kind of going forward. So I think there is value in having some like structure, especially in a repeatable kind of way over like your data, and being able to have kind of control and consistency with that structure. To fit into like existing kind of data pipelines and workflows that people already have and systems that they already have. But I also think that there's additionally new ways that we can interact with unstructured like data and content that we couldn't do before, in terms of like multimodal search, like going from text to being able to search for like an image or a video, also similarity search and things like that, where you don't have like, I guess in a sense, there are these kind of, you might be able to do something like this in like structured data, but like it really kind of comes into its own when you think about unstructured data and being able to do those type of, other forms of queries beyond just kind of traditional structured queries, like image-based queries or similarity-based queries or like multimodal-based queries. So I think we're going to see a variety of ways to work with unstructured data and content kind of going forward. But one thing that I think like hasn't been explored yet is like, you mentioned like the Google Vision API and things like that. I actually kind of like in data systems, there's this notion of like, transactional databases and analytical databases in a sense, right? Where transaction is like, very small, like kind of operations, only touch like a few rows, and it's supposed to be very low latency and very fast for a bunch of transactions. And then you have analytical workloads, which are going to be touching a larger portion of the data, maybe a little bit less latency sensitive. I think we'll have kind of a similar thing in like working with kind of unstructured data and AI, where I think a lot of these like vision APIs are more like transactional workloads. It's like, hey, show me one image at a time, and then give me like some data about that image. And I think fits into the transactional thing, but I think we're missing kind of more of this like analytical piece where we want to look at like a large collection of unstructured data and content. Like right now, we really don't have the tools to kind of do anything with like large amounts of unstructured like data or content.
Well, we didn't have the tools.
Well, we didn't. Yeah,
we have Coactive now. But anyway, that's related.
Yeah.
No, I mean, plus one, everything Cody's saying. I think if you take a step back, like a lot of what people are doing with unstructured data boils down into kind of like two very broad categories. One is like that of intelligent search. Again, to Cody's point, like maybe you have an image, maybe you have text. Maybe you have a stateful search, right? It's kind of like the whole notion of like ChatGPT, even when folks are just searching for things using it, right? And then on the other side, you have the analytical side of things, which is you have 10 million, 100 million images, right? And you want to say, hey, like, can you give me like how many of this type of object are in it, right? Like I have, I have a bunch of say like images of like Star Wars, right? Like, hey, like how many Baby Yoda images do I have in that, right? Like how many images have been uploaded in the past hours? These kind of analytical queries, I think, is like is a point that's often missed, but is the bread and butter of what a lot of people do in data, right? And to Cody's point, like a lot of these solutions don't address that very well. Like if you have the computer vision, Google's computer vision API, GPT-4 just came out, and you give it an image, it gives you an amazing description, right? But like that becomes prohibitively like expensive, both in time and dollar amount. Like I say 1 billion images, right? So how do you deal with that? And I think that it's interesting because that point is often missed. But yet it's a very, very like useful use case. It's just like people don't really have the tools to do that right now. So it feels a little bit more like, well, we don't do it because we don't think we can, right? And that to Cody's point, like, yeah, it's just really an underserved part of it. And for that view of the world, to go back to your original point, right? I think given unstructured data some form of structure does really facilitate it, right? If the lingua franca of data so far has been SQL for like how many decades, right? If you could have some notion of structure around your structured data, then it allows you to do SQL queries on it, then all of a sudden that becomes extremely powerful. the end user.
I mean, sort of an interesting anecdote. I mean, I've been flying internationally quite a bit recently, and even the notion of a passport is sort of, it feels antiquated because all I need to do is just put my face in front of a camera now. And it's like, that's it. Okay. I have global entry, so a few weeks ago I got back to the U.S. and literally went through immigration in like 4 seconds.
Yeah.
I mean, if you think about that, that's kind of nuts, right? The amount of lookup that it has to do to assess that, I think it's like pretty insane. I get to France this morning, and it's like they didn't even bother. There's like, stamp a passport, get out of here. Didn't even look at anything. So because I already did the image check-in when I had boarded. So
Joe, in all fairness, you're also world famous now. So
Yeah.
There you go.
True.
Yeah,
Yes.
you won that last
Well,
one.
why are you in the line with everyone else? Why don't you- no, but it's interesting because I was just thinking about the amount of processing, that has to go on behind the scenes to infer that I'm, that person.
Yeah.
If I wear some goofy glasses, it's like it still works. It's interesting. Actually, Maya has a question. Song, what were you saying?
Oh, no, I was just going to say that's actually a great point, Joe, about just like the amount of processing that you have to do, because I think this is one thing that people actually kind of miss with like, why is it so difficult to work with unstructured data in comparison to like kind of more structured tabular data? Like, as an example, imagine we had 10 million rows of tabular data. Like that's going to be about like 40 megabytes. And like for kind of like, an analogy here, like let's imagine that kind of equates to like Lake Tahoe, we're in the mentality of like data lakes. Lake Tahoe is like square, like
it's like 400 square kilometers.
Yeah, it's about 400 square kilometers, like surface area of Lake Tahoe. If we think about textual data, like if we had 10 million documents like from Wikipedia, I think that's roughly 40 gigabytes of data. So that's 3 orders of magnitude larger than like the tabular data for the same number of records. And if you were to kind of like go with this analogy, that's kind of equivalent to
the Caspian Sea. We looked it up, but it's like you go from like Lake Tahoe.
Oh wow, you guys actually did this.
That's pretty cool in the world, right?
Yeah, exactly. Yeah. We looked up like, because it's like it kind of makes it like make sense of just like how big and different the scale is. Like, it's like Caspian Sea, which I think is around like 400,000 square kilometers of surface area. And then when you think about images, if you have 10 million images, like the Open Images data set, that's about 20 terabytes of data. That's another 3 orders of magnitude on top of that. And that's like equivalent to the Pacific Ocean, which is like roughly like 168 million square kilometers of surface area. So like right now we have tools that work for like data lakes, which is kind of like, but like thinking about the scale of something that's on like the Pacific Ocean, right? Like the same tools and vehicles that work for a lake aren't going to necessarily get you across like the Pacific Ocean.
Yeah, you go from something that like it's trivial to hold a memory to something you can barely hold a memory to something that it doesn't even make sense to work outside of like an object store in the cloud, right? And these challenges, I think, are often underappreciated once you start to tackle it. So even within unstructured data, there are these nuances and these idiosyncrasies in each of the types of modalities that I think are often missed. And I think that's going back to your point about the different systems. I think you really have to have a best-in-class solution for each of them, right? Even within video, right? Like people sometimes miss that, like there are very different forms of video. There's like short form, like TikTok, 15-second videos, and then there's like hour-long podcasts, like what we're doing right now, right? And they both have to be processed very, very differently.
It's really interesting because it kind of makes you think about what sort of the objective functions that are yet to be, I guess, used. But as more and more use cases for unstructured data come into play, it's kind of like, what else could we really do with this type of data that we haven't thought of yet? I think it's interesting. Generative AI, I think, is going to kind of blow could blow the lid off a lot of things. But I think that kind of letting people's imaginations run wild with the possibilities of unstructured data that's going to be very fascinating to see. Like on my plane ride over, somebody was just talking about ChatGBT, and it was just a couple just talking about it, how it's going to be in office pretty soon. They're very excited about this. And it's like, that's kind of cool. Like, it's sort of when the internet became popular, everyone started talking about it, and it feels like AI sort of is having that moment right now. And So it's interesting. But on that note, Maya actually has a question here. She says, is there a concern that generative AI may inadvertently normalize unstructured data and thus accidentally remove / gloss over outliers that are signals in the noise? Any thoughts on that?
Oh, this is a great question. Thinking about it, I'm trying to like process kind of everything. So normalizing unstructured data, thus, so I think there's definitely a lot of concerns when we think about generative AI. I think that there is this notion that will normalize unstructured data in the sense that being able to generate kind of unstructured data in the form of text, images, videos, all this stuff will become, very commonplace, and it will become, we'll just generate a massive amount of this data, and folks will get so used to like the notion of like working with unstructured like data or generating unstructured data in the same way that we can generate traditional structured data, and we don't even think about it. In the big data movement, it's like this data, structured data is everywhere, like literally. It's just the like, every single time you take an Uber ride and things like that, you're going to be generating structured data. And in comparison, like structured data to unstructured data, structured data has some like notion or like some intention around what each one of the values are. It's like supposed to be like, hey, this column is like the rating that you gave that ride, if we're thinking about Uber or something like that, and there's some kind of intention and things like that. And there's like maybe less outliers in a sense, whereas like unstructured data, it's unstructured for a reason. You don't have that kind of schema or anything like that. So like the inputs that you could get and like into the system and that data that's captured, can be like highly variable. I think this is where we see kind of the long tail, like trying to tame the long tail in content and just like data that we generate overall. So if I'm interpreting this question correctly, I think I agree with the notion that, structured data, we have some problem with like outliers or issues and like the data, like null values and like values that we don't expect. I think that gets exacerbated when we think about unstructured data, just because of like the universe of inputs that we could have and like data that could be like kind of generated there, where the failure cases or the failure modes are like very, very numerous, kind of coming back to this long tail. So I think that that's like a really interesting problem. And I've seen this even like kind of firsthand with just like simple kind of classifier definitions and things like that, for example, was just trying to say like, hey, are images bowling or not bowling? And you would imagine that should be like a simple question, it should be like either 0 or 1, it's bowling or not bowling. But there's a lot of edge cases that, like, if you think about kind of AI, that you might not anticipate, So one was photos of an exercise studio when I was doing this kind of process of active learning were shown to be very uncertain by the model because they would have a wood floor and giant colorful exercise balls in the background, which, like, when you look at it from a machine's perspective, I could see how it would get confused that this is actually like a bowling alley and things like that. But like as a human being, I would never have thought to even include an example of an exercise studio with like exercise balls in the background as like a kind of training example for this bowling classifier for anything that I'm doing there. That's maybe an innocuous example, but you can get all sorts of kind of more problematic things when you think about trust and safety stuff, when you think about kind of like generative AI being kind of put into a bunch of different domains, like even Microsoft Office, for example, where you have to think about sensitive information and things like that being linked as you connect it to enterprise data sources. But hopefully that's like my take on the question and maybe some context around it. But I don't know.
Yeah, no, I think plus one what Cody said. I think just to give like an example, right, is like, So with traditional, like when data is being generated, like unstructured data in particular, right? Like you're effectively rate limited by like humans, right? Some sort of human interaction or humans doing something, right? If you're no longer rate limited by that and you can generate a lot of content, right? Specifically, you're going to be asking to generate curated content. Then there's, when it was just humans, there's kind of like these broad notion of concepts with these very long tails, right? If you're now creating a lot of content around maybe not the tails, but just like the meaty part of the curve of the things you care about, you might have a representation of maybe what is not human-based data. So, I mean, to give you an example, going back to the trust and safety use case, right? Let's say you have like let's say you have a platform of user-generated content, and say you now start just making it to pretend you have users, right? Well, you might be missing now the part that like users, like there is some non-trivial fraction of users that like to put troll posts, right? Or like to create new memes, or like to perhaps upload gore, because I don't know, for whatever reason, that's something that you have to worry about in user-generated content. But is the reality, right? I think to go back to Cody's point, right, is just I think just being thoughtful around like hey, like, you know, is what is being generated representative of what humans will generate, right? And if it's not, at least making somewhat of a distinction.
Yeah, what was it that it came out? Was it Glaze or something like that allowed you to sort of trick? Was it? It was a way of like sort of obfuscating the data, but it was something that humans wouldn't be able to detect. So if you threw in this thing, and I'm totally butchering it probably, but it would into an image, like, you know, it wouldn't be able to be copyrighted, for example, or something like that, or it would be it basically watermark it in such a way that you know, it could pass through it would spoof the learning algorithm somehow. I'll have to look this up there, but
Yeah.
Curious if they get. I imagine you'll see more of this kind of stuff. Really, it's sort of like cloaking whatever. If you don't want your stuff to be picked up either by an algorithm, you find a way just to throw some noise in there so it doesn't get picked up. So,
Yeah.
When CatGBT came out, the first thing I thought of was, oh, geez, we're going to have basically the equivalent of like SEO happening with these chatbots. People are just gonna be throwing out all kinds of crazy stuff, and this is.
I mean, I can tell you that's definitely happening, right? You guys are probably very well aware of this. I mean, people are definitely.
You should buy my new TikTok course on how to become a millionaire on ChatGPT.
That's
right.
I'll
tell you all about this. But I remember in the GPT paper, the original one from 2020, they actually had an instance too where the test data and the training data got contaminated with each other. So happens.
Yeah. I mean, this is like, I think you touched on so many different kind of like problems or like areas there, like Joe, to like break it down. Like one, I think there's this like, there's like one is just the sheer skew of data, you know, and I think this is like one thing that can happen where people can easily like flood, you know, like bad content, misleading, misinformation, and things like that. Also, like you can just skew just like general populations, like the people that are already talking a lot can now talk more and like will dominate the airways even more than like kind of other folks potentially. But the data piece, actually the data going into training these models and stuff like that is also like a really, I think, underappreciated part of like AI in general. Like, you know, OpenAI, like they're really, really smart as like, you know, an entire team and an organization. But even they messed up like kind of their sets at that scale, you know, when they're scraping the entire web, like they might have some hidden test set, but that test set's like exposed somewhere on the web. And like even trying to understand, you know, what data you're training on and what data is being used can be like hard to understand at that scale, again, because you don't have like any easy way of like looking at like massive volumes of this data and like a single go, or even understanding like, again, this like ocean of data, ocean of unstructured data that's out there. And even they also had like issues back in the 2020 paper of like even figuring out the distribution of like how they mix in like Wikipedia data with like the common crawl data from the internet to make sure that they have like high quality information from like Wikipedia versus like, you know, plentiful but low quality information from the internet. And then of course, like dealing with bias and stuff like that you would have on the internet, and trying to like, you know, moderate, like kind of manage that so that it doesn't get kind of crystallized and amplified in like this ML model and then propagate it kind of over the web. Like, you know, back in the day, I always think of like Microsoft Tay. I'm not sure if
Oh, I remember Tay. That was hilarious.
How many hours till it became like a neo-Nazi?
Under 24. It was.
Was that one of the first examples of that? Because since then we've just kind of come to expect it, right? I mean, where you constantly have to put safeguards in to protect from this kind of behavior.
Well, I think that scared the living daylights out of a lot of companies and people. It's like, wow, this thing could be spoofed by Twitter. I mean, Twitter is a great, wholesome, family-oriented place. So I was shocked when that happened. And the internet itself is a very yeah, it's a great place. The internet's a great place. Totally harmless content out there. I mean, I don't know what could go wrong. Yeah, it was crazy. But I think you saw that with, what was it, Sydney as well. Some weird variant of that, which was the Microsoft's thing when it went on Bing. Suddenly it was like,
and Galactica,
kind of
Facebook or Meta Galactica that came out recently had the same problem essentially. Is that right?
Yeah.
They pulled it within a day, basically.
Yeah, I mean, it's just like such a massive problem over like even OpenAI, right? Like one of the big things that they did with like ChatGPT is they got much better at kind of, holding it back and putting safeguards in place so that like you don't have like, sensitive content, stuff like that. And it's quite interesting to see like sometimes those safeguards are like so strong that like the AI just has to bow out of like anything that's even near like a topic that might be like somewhat problematic or get into the space, like talking about religion or gender or sexual orientation. Like these models just give up. They're like, okay, they like have like a hard rule to prevent it from going down that track because it can be so problematic.
oh geez, yeah.
Here's another scenario going back to what we were just discussing. So one can imagine a world where maybe 90% of the content on the internet is machine generated. I mean, it's not hard to think of this happening looking at just the volumes of generative AI. That's just what it's pumping out. So do we have to worry about a scenario where the internet just becomes one giant like generative AI feedback loop on YouTube or something?
There's an Onion News. I think there's like one of those fake tech talks exactly on this, where it's like, oh, right now we have bots, then later on we'll have bots generating content. And at some point, it's just bots chatting with each other. We're completely out of the equation. And like everyone claps.
I could make actually a strange argument, because I do that once in a while, about how I mean, SEO in some ways is sort of already you've already done that, right? I mean, you've already kind of fit content to fit an algorithm. It's just it was human generated, but now it's just now that's automated. So I mean, it was funny. I was walking around an office here in Paris today, and somebody was actually using ChatGPT and was like reading the results and then typing it into something else. It was an interesting workflow. I just stood there for 10 minutes.
Copying it?
Typing it. Yeah. I was like, what do you know that you can, there's other ways to do this. I'm not going to tell you. I don't speak French. So it was really fascinating because people are just using it in their workflow. And I think they're just trying cherry picking whatever answer they found. And then, and as Scott Taylor says, if you put garbage in, you might get garbage out. Yeah. I mean, it's strange. Does happen. Mike Nash actually has a kind of a question that's a bit more on track here. How important is compute and storage cost for unlocking value from unstructured data? Will file optimization be key to the future of unstructured data management?
Oh, this is a super great question.
Yeah, this is a pretty good question. Oftentimes, this also gets like honestly kind of ignored. Again, going back to the analogy of like 4 megabytes versus 40 gigabytes versus 20 terabytes, right? Sorry. Go ahead.
Oh no.
Yeah, no, go for it. This is a good question.
Yeah. So ultimately, I think that we need to kind of think many different parts of the stack. I think storage is like one really important piece of it. As just like a simple example, when you think about like working with a large amount of images, or like the starting point for a lot of companies is that they have like their images or multimedia files stored on an object store like S3 as a bunch of like PNG or JPEG files, right? But having like a bunch of images just stored on kind of a distributed object store file system is like really like poor from like a traversal kind of like search perspective, and like from kind of my experience in like MLPerf and Dawn Bench, like the first thing that people do to be able to like kind of optimize or get kind of better performance out of like their ML systems to like kind of train or even process this data is that they take kind of these raw files that are scattered across network storage and they actually just kind of compile them together into some type of binary format, whether that be like something like LMDB or HDF5 or Parquet files and things like that. Because reading like one file from like one, it compresses the size, it'll reduce the size, and it'll also prevent you from just having to make all these reads out to the network. and you can instead like kind of like have a big bulk file that you process, is huge for being able to get the like orders of magnitude kind of like improvement in performance, and to really be able to saturate these accelerators, because we have this kind of whole thing that's happening, like hardware manufacturers, they see kind of the value of all this unstructured data, of AI, and being able to process all of this. So we have compute that's getting faster and faster and faster. And we actually need the data and the storage layer to actually be able to keep up with the speed of these like new accelerators and things like that, for us to be able to get the value out of that. So I think storage file optimization is like it's not fully sufficient in a sense. Like, I think it's a necessary condition. There's other things that we need as well in order to be able to unlock the value from unstructured data. But like file optimization, optimize like data management for unstructured data is like a huge piece of that.
Yeah, I mean, just like practically speaking, right? Like if you truly are like, to get a lot of the value of unstructured data, you, for the most part, you're kind of going, you're not using, I mean, you can use humans, but it's a very expensive, very expensive, slow endeavor, right? So you're generally using AI, and in the context of using AI, you very quickly find that the larger these file sizes and the more that they are of them, like what Cody was saying, like you become IO limited super fast. Like you end up having like, oh, why is my GPU utilization like 10%? And it was like, because you're reading from S3 the whole time, right? You're just reading all these small little files, right? And again, you can do these tricks and you can do all of this, but yeah, I mean, exactly like Cody's point, like there's very little thought that gets put into it a lot of times, and you as an ML researcher end up paying the price downstream, right? So yeah, so just better playbooks for really storing this data and also accessing it are incredibly important to this piece of getting value out of unstructured data. Yeah, again, it's you need a lot more than that, but this is like a key pain point as you go to these like giant files, or either giant files or large volumes of data, or a lot of small files that ultimately add up to a lot of data, right?
And one bigger point that this ties into is that there's like a lot of steps and a lot of this, like, like doing Dawnbench and MLPerf, I got to basically kind of see high performance deep learning. And there's a lot of this kind of like just knowledge out here, like little pieces of knowledge and little kind of components of the stack that matter a lot in order for like to be able to actually like process this data efficiently. Like I've seen organizations as we like work with folks where they have to spend, tens of thousands of dollars in like a month to compute something that, like, if you look at like the best results from MLPerf, could be done in an hour, and that's like, it's orders of magnitude different, like in terms of performance and cost, if you are able to do these optimizations and be able to get to like the best performance. Like the best performance for like inference over images, if you look at MLPerf, was something like 300,000 images per second, which is like massive. That's like huge and amazing in terms of just like being able to like churn through this data really, really quickly.
Yeah. And I think another point I was going to make too is a lot of these problems of having like a lot of data or small files like become more and more present as you go towards like the unstructured route. So to give an example, right? Like as you're doing this kind of inference, inference pieces, like we have a lot of like really small files. Oh man, my train of thought like just kind of killed. I'll come back to this, but like this is like man, sorry, this is just the analogy I had gave me, but yeah, I'll come back. Sorry.
All right,
Don't worry about it. It happens to the best of us. I mean, what is the crux to unlocking the value of unstructured data? What would you consider to be the hardest thing?
Oh, can I this actually relates to this question. I just came back to me. Sorry.
Yeah.
Cool. So again, want to go back to like the kind of like storage piece, like question that's actually pretty related to this, right? If I think for a long time, people in this big data space have been in this world of data quantity, right? Like if you have millions of noisy examples, that's fine, traded on all of it. And that's kind of fine when you're doing unstructured data that's just tabular, right? When you go to unstructured data, all of a sudden, like training on all of your noisy data, it is a very expensive endeavor. I think this is what folks like in the AV industry start finding out. So if you stay in that world, it's going to become incredibly expensive to keep operating in this data quality doesn't matter kind of world, right? And we can just get all of it. But if you're actually really thoughtful about not the quantity of the data, but the quality of your data, right? You find that yes, you can get to a certain performance with millions of noisy examples, or you can be really tough about the quality. You can have hundreds of examples that actually end up learning kind of the same behavior, like or the ML model ends up learning the same patterns. If you were just think really carefully about like this data selection piece. And I think that's something that's often underappreciated. And I think once you go to structured data, you have like sometimes you have no option but to employ some sort of data selection strategy because you just can't train on everything because of how prohibitively expensive it is. And this actually kind of ties into the question you just asked, Joe. I'll let you take it.
Yeah. So coming back to that question, I think it does tie in nicely of like, what is the biggest kind of blocker for people to be able to unlock, the value of unstructured data? Again, ultimately, I think we're going from like data lakes to data oceans when we think about just the sheer volume that we have with unstructured data, especially if we think about kind of visual content. And as a result of that, it forces us to have to rethink all the systems and tools that we have. However, I think there's a lack of people. I think that there's a lack of like, you need to understand kind of both pieces. You need to understand AI, and you also need to understand systems in order to be able to create kind of the tools that like work here. And I think that's where a lot of companies kind of mess up when they think about unstructured data, or even like, using AI in their teams. They like focus on one or the other. You have like, you talk to like a systems person or a databases person, they're just going to be like, they're just going to be like, just like shove it into some existing tool and system and things like that. Yeah. And it's like, it doesn't work smoothly, and it requires you to like kind of do a bunch of hacking. As an example of this, I remember Microsoft had this project like Raven, which was to put ML into Microsoft SQL Server. The way that they decided to do that is like, yeah, let's take the entire Onyx runtime and just like shove it into Microsoft SQL Server, which is like, yeah, like that. I guess you kind of put ML and databases together, but it's not really an elegant kind of cohesive solution. You just kind of like duct taped AI to a database, which like is not going to be the most elegant or best way to unlock the data. And then on the flip side, when you think about like, I think like ML people and like AI folks, they might not, they'll miss some of these systems components, and like, how do you actually think about the scale or cost of these things? And how do you make like the data piece of it repeatable and like kind of understand the broader like atmosphere of it? And I see a lot of organizations, they like hire like a few ML people, and they like kind of aren't setting them up for success. They're like, hey, they like basically have like this massive heroic task of like trying to like train or build a model over all this unstructured data, but it's so painfully slow for them to like even iterate or process or do any of this because they don't have the basic infrastructure in place. That becomes kind of just like a like ridiculous like challenge that they can't overcome. And I see companies, they do this and then they like end up basically failing. They build like they try to build some prototype, they fail at it, and then they kind of give up. They waste time, they waste money in doing that.
Yeah, and I think I'll just add a few points to that. I mean, plus one, everything Cody said. And I think what's really interesting is like the ML and the AI folks a lot of times don't really necessarily talk or interact all that much. I think it's very far and few, like the Venn diagram intersection of the two. And I think on the ML side, it often gets underappreciated. Like when you go to like large data sizes, just how hard it is to just move data from point A to point B, right? If you're talking about like, again, like a toy data set that you have on your laptop, that's like, again, like 20 gigs, like, it's fine. But if you're talking about like 20 terabytes, all of a sudden, like that is like a non-trivial challenge, right? It's underappreciated by the folks that are just purely doing ML. And I think from the data systems side, like sometimes it's underappreciated the nuances that ML brings, right? Like, for example, say you are to create some sort of like column that's like a structured data column based on your own structured data, right? Like, is that an ephemeral column, right? Is that like some temporary view that you create on demand? Do you persist that, right? All these questions now come up that actually heavily interact with the AI piece, right? Because is that a model that's constantly changing online based on, say, demand, because it's a transactional kind of a operation, right? Or is this something that like, hey, no, that's like a historic model that's never going to change, right? which is probably not a good idea. But it does open up a lot of these like can of worms and questions that I think because the people are oftentimes not in the same room, or maybe in the same room but maybe speak a different language or have different training. It's just these questions kind of get missed, but they're incredibly important to doing unstructured data plus like AI. They're making sense of the whole equation. So yeah, I think plus one everything Cody said. I think the system side of things can be understated enough. Like as you go more and more unstructured data. I mean, and frankly speaking, like I feel like a lot of these questions have kind of been punted because a lot of the focus on AI so far has been on NLP. And when you're within the realm of NLP, it's stuff that you can still do on your laptop, right? You haven't gotten like, but the second you hit images and video, and like the people that have had to work with that, like you very quickly understand that like, this is just like it requires a different scale of tools and it requires a different scale of like of thoughtfulness, right?
Yeah, and closing it out, like like coming back to like the social media like title on LinkedIn, Joe, of like content is like the new king. Like all this unstructured content is like massive, and we see generative AI making the ability to create content easier, faster, and things like that. But like AI is the queen in the sense that is that key piece to being able to actually unlock that value. So like the like bringing data, content, and AI together in a cohesive relationship that is like the key piece to actually being able to get that value.
Well, it sounds like this expertise, like the systems level expertise plus process level expertise. And by process level, I mean like just understanding how do I pre-filter my data? How do I cut down data sets? How do I reject noise before I even start training? It sounds like that kind of expertise is going to become, or already is, a key bottleneck in the development of AI. How do we train a new generation of like AI practitioners to get beyond their laptops to have that systems level and process level thinking?
Or is it a person that does that at all?
Maybe. Yeah. GPT-4 is going to do it for us.
Yeah. So super great question, Matt and Joe. I think ultimately the way that like actually to Joe's point, I think that I think for most enterprises, most companies, like expecting them to be able to build out their entire like the ML team, the like data team, and the systems team to do this is just like almost too big of an ask like for them, right? Like already it's like really expensive to build out like an ML team. To do all this other stuff is really, really hard. And I've seen that firsthand. I've seen kind of like the infrastructure and teams that are at places like Meta and Pinterest and stuff like that. So I think that like, and this is like, again, the whole reason that we created Coactive is to actually like create the tools, create the infrastructure to bridge that gap so that you can work with like your unstructured data. And it feels as though it's as easy to work with unstructured data as it is to work with structured and semi-structured data. And we can fit into the existing like pipelines and workflows. So like many organizations like don't need to like worry about that and think about it, because I think that it is really, really hard to get this right. Mm-hmm. But to Matt's point, like we are doing stuff. I think that there is like changes that are happening in curriculum and things like that. We're heavily involved in this whole new movement around data-centric AI, which I think is, a step in the right direction in terms of like not just thinking about AI in terms of models, but actually thinking about the data that goes into those models. Yeah. And then, like from my PhD and like from the ML ops community and things like that, I was a part of like ML systems and like the ML systems community getting created. Like my advisor at Stanford, Matej Zaharia, and Peter Bayless, they created like the first conference on ML systems. So I think now we have like we have two things being joined together. It's like data and AI and systems and like AI. Ultimately, what I think we need is like kind of all three of those pieces. And I think that's where the magic really happens. But that only ends up happening in a few places, like when you think about like the step functions in AI or like data, it was like you think about AlexNet back in like the day on ImageNet, it was that trifecta of super large data set at the time of ImageNet coming out, plus like deep learning in terms of AI. And then they just did like a ton of GPU hacking to be able to train like the model on that large scale of data. And then fast forward to now, when you think about OpenAI, like OpenAI is like another like like the AI stuff that they did is like interesting, you know, like in a sense, but it's like more of the same. It's actually what I think is like amazing what OpenAI did was just the scale that they were able to process things at, which is really like a systems like problem. And like also being able to like kind of filter the data correctly to prevent, you know, ChatGBT from becoming the next Microsoft tag. So those places, like when I think about like reflecting on like time, like the time and kind of the inflection points and like unstructured data and AI in general, it's really when you get that trifecta of like AI, data, and systems together. But there's only been a few organizations and places where that can happen. So I think realistically expecting all companies to get to that point is like kind of hard because they are very deep in different disciplines. So I think the tooling and the infrastructure, I mean, there's a lot of people that are trying to deal. I think the space is exploding right now. It needs to probably settle out a little bit in terms of like kind of tools, but I think we'll get into a place where like there are best practices and standards in the same way that there's like standards for like relational databases, you know?
It definitely feels like that. I mean, I've been, you mentioned relational databases. It's funny. I've been writing a new book on data modeling and have been going back through the corpus of database history, really fascinating topic. But right now, it feels like the last 10 years is really where databases were back in the 60s and early 70s, where there were actually many forks it could have gone. Hierarchical databases, relational databases, and so forth. Like it wasn't really, well, the big vendors kind of decided where that would go actually. Kind of like today in some ways. But because I mean again in the original GPT-3 paper, it's like when I was looking through it, I was like, oh, they're just using deep learning for this stuff. That's the same stuff that was used in the ImageNet way back in the day. And so, you know, but as you say, it's just a scale, right? And so it's very curious. What was also curious about GPT-4 was it wasn't, they didn't scale it out as far as I could tell. Maybe they did and they didn't say it, but you know, it was more just using like human reinforcement in the loop and including kind of more of a multimedia mix, but which is pretty cool to see. I mean, the example they had of like an iPhone with a VGA cable strapped to it was pretty hilarious because it was able to tell what it was. But it really feels like we're that kind of a very similar situation with databases. And I'm glad you brought that up, Cody, because you know, it feels like things are just getting started, I guess is what I'm getting to at, you know, and who knows what the next, 5-10 years, but I think you guys are definitely onto something. Like I think very, born from experience too. It's not like you could have just made up a startup like, oh, we're going to go tackle that problem because that seems really fun to do. It would have required like a very unique insight that you would have only have gotten if you're paying a very close attention to the nuance.
I think you also have to really love nerding out about this kind of stuff because it's deep. It goes very deep in both the AI and the systems direction. So yeah. I mean, luckily we're both like nerds at heart and we love this stuff. So this works out pretty well.
and old friends too. I think there's a lot to be said for that. Yeah. You guys kind of know how each other work and vibe off that. Yeah, that's really cool.
The fundraising situation right now is nuts, though. I mean, just there's so much money going into generative AI from VCs at the moment. Maybe that will change with the.
Oh yeah, Matt and I are going to announce our new generative AI company. That's right. Actually, after the show. Kidding. Yeah, my grandma, she's going to announce hers too. It's quite the world we're in right now.
You know, in the future, this podcast could all be generative AI.
Yeah,
you know, it'll be like,
oh, totally, it will be. It will be. Yeah. It's what a world. So, well, awesome. It's good to talk with you guys. Love to have you back on it again at some point. For people who want to learn more about you and what Coactive's up to, how can they do that?
Yeah, so they can visit our website, Coactive.ai, or follow us on LinkedIn at Coactive.ai, or also on Twitter.
Awesome. Cool. And I know there are quite a few questions here, and sorry we didn't get to everybody's questions. Time flies and you're having fun. I guess if Cody and Will, if you want, you can go back to the questions and answer them in a written form or not, whatever you're into. So yeah, there were some good ones. Thanks for everyone for showing up. Next week we have Jess Haberman. She was our acquisitions editor at O'Reilly, actually, and I think we're going to talk about. Now she's at Anaconda, I think in charge of learning or something like that. So, we're going to talk about education, learning tech, writing books, and all that fun stuff. So if you've ever wanted to write a book, for O'Reilly, I think Jess is maybe a good person to get some advice from, or if you just want to learn about tech, she's a good person to talk to as well. What is it, Matt? Friday, we're going to be in Verbier, Switzerland, doing something.
Yes, we are going to be at the Skiers in Data conference with Chris Dabb and Leading Edge IT. So yeah,
cool. But what we're doing, are we on a panel or what? I can't remember.
I think
anyway,
you're on a panel.
We're all pros with this stuff. Yeah.
We're going to be talking about data modeling and streaming, actually. So we're going to be talking about the problems as we're shifting toward a more like streaming first real time data architecture. How do you think about data modeling? So which actually is something you've been thinking about a lot, Joe. So we've had a lot.
I have, but I'll save my my blurting for the panel or show. So anyway,
Yeah, Joe, I was gonna say we've also been thinking about it from our end because I mean, structured data is going like live streaming and video and those kind of interactions are super important. So how do you like do all this stuff? How do you do it in real time analytics fashion? It's a fun problem.
Love to chat. So because one section of the book is definitely going to cover streaming and machine learning. And maybe a mix of the two. Yeah. So it's about how do you model data for ML too. So a lot of the stuff we talked about is actually very, very pertinent. Like, when you talked about quality data, Will, it's like that. It's like, that's something we should be thinking about. So it's So anyway, love to chat soon. Great having you guys on. Thanks to the audience again. Great questions. Glad everyone liked the show, and we'll see you next week. Take care.
Awesome. Thanks, Joe.